Hi guys, in this video I'm going to talk about difference between hard computing and soft computing. Before we begin with the difference between hard computing and soft computing, let's know what is hard computing. Hard computing is when you make a program to solve some particular problem, that is hard computing. Soft computing is when you make a program that learn by its own or that automates how to solve a problem, that is soft computing. Let's begin. Hard computing. In hard computing, conventional computing require a precisely stated analytical model. Whenever you have some precise information given, and with precise information and using analytical model, you begin in the hard computing. Whenever you are computing and you have some precisely analytical models, there are different analytical models which are given. With the help of this precisely stated analytical model, we begin in conventional computing. In soft computing, it is tolerant of imprecision, uncertainty and approximation. Role model is human brain. Whenever there is imprecision, tolerant of imprecision means when you are uncertain that what is going to happen next, then we are going to use soft computing. Here our role model was analytical models. There were different analytical models. Different analytical models were, you have given sets of information based on how you are going to compute, like you are creating a pie chart, bar graph using some of the algorithm. Here our role model is human brain. You are creating a program just like a human brain. How our human brain works, like based on neurons, how information is transferred from different neurons to other neurons, and now output is produced. So here role model is human brain. Hard computing, it takes lots of computational time. As you have written sets of code to solve some problem, then definitely it will take some time to solve a problem. Like you create a problem for chess using some AI algorithm, then it will take time to solve sets of problem using some algorithm. But in soft computing, it takes very less time of computation. As here the role model is human brain. So suppose for a given statement is given and it is asked that how many vowels are present. Just by looking at the statement you can answer. So if the computing is based like human brain, that how human brain works, then obviously the time taken for computation will be very less. It is based on binary logic, crisp systems and numerical analysis. Binary logic, that is 0 and 1, that is either true or false, that is whether a given statement is true or false. Crisp system is our fundamental logics like negotiation or contradiction method or De Morgan's law. So these all are in the crisp system. Numerical analysis, different sets of numericals problems are given, and based on numericals on sets of data, how you are going to manipulate that data, that all comes in hard computing. It is based on fuzzy logic, neural nets and probabilistic reasoning. Obviously soft computing handles the approximation, uncertainty. For solving uncertainty and probabilistic reasoning and fuzzy logics are used. It requires program to be written. Suppose you are searching sets of element from a given list, that is who scored the highest number. So you are writing a particular set of program. So in hard computing requires a program to be written. But unlike in soft computing, program can evolve its own program. A program is there, it is written such that, or it is, you can say a software is there that it will write its own program, that tomorrow whether what is going to happen in the weather forecasting, then it will evolve its own program. That is, if it is raining, if it is climate is humid. So based on the given information, it will write its own program to solve the problem, to predict the uncertainty. It uses two-valued logic. Here logics are two-valued, that are either true or false. A given statement is either true or false. Like, who is going to be the Prime Minister next? So it is fixed that whichever the political party wins the particular sets of seats, then the Prime Minister will be from that particular political party. It uses multi-valued fuzzy logic. In soft computing, we use multi-value fuzzy logic. Just like the example of forecasting, there can be different parameters, like raining can be another parameter, like wind can be another parameter, humid can be another parameter. So whenever there is some uncertainty, then you have some multi-valued logics. Multi-valued logic, that is, they are not completely true or completely false. Now you cannot completely say that tomorrow definitely it will rain, because it is uncertain that where there is humid, there is rain flowing, there is wind flowing, but still it does not rain. So whenever there is some multi-valued, then we use multi-valued fuzzy logic. Hard computing is deterministic. Hard computing is deterministic means it is fixed. It is fixed to solve some particular set of problems. That is, it will work only when you have the information present in a deterministic manner. But unlike in soft computing, it incorporates stochasticity, that is randomness. Suppose any randomness occurred in any program, that is, you have a program to check the temperature variation and there can be some unrandom temperature, then whenever there is some randomness present, then we are going to use soft computing. Hard computing require exact input. Whenever you have some exact inputs, like for a program you give sets of inputs like 2 plus 4, then answer will be 6. So it will, in hard computing we require exact inputs. But in soft computing we can deal with unambiguous and noisy data. Suppose data is flowing from different sets of network and that data has become noisy, or that is unambiguous, that you don't know whether that data is correct or not, then still our soft computing will work. Why? Because here we have some approximation techniques. With the help of approximation techniques, we are going to handle ambiguous and noisy data.